So we'll take a few minutes to look over several questions that are like the ones on your test. These are not the test questions, just similar to it, so you can get a little bit of a review before taking it or while taking it. So number one here, we're integrating. I think you're pretty good at these by now. You can kind of just put the answer in there. If you know it, realize this one's negative. So thinking ahead, we know there's going to be a 1/6 out front because of that. So our guess is going to be negative x to the 6th plus c. You can check it by taking the derivative. Is going to be the negative 6 comes out front, x to the 5th. Oops, I wrote the x twice. So it does work. The other thing well, let's move on to the next one and we can see some other things. Again, you might be able to think through some things here to work through your constants. But what we're going to do here, this integral can be split into two integrals, and we'll do each one at a time. And at the same time, what we'll do is we'll change our radicals into exponents. So here, the first one we're going to have, we'll just bring the 25/3 out front because that's a constant. And then this is going to be x to the 2/3 dx, and then we're going to subtract the other one. The 25/4 is a constant, so it can come out in front of the integral sign, and this is going to be x to the 1/4 dx. And now we can integrate. So thinking through this x to the 2/3, that's going to go up by 1. So 2/3 plus 1 is 5/3. The 25/3 is still here, and then we multiply by the reciprocal of the exponent here, the new exponent. So then we have minus 25/4, and then this is going to be x. This goes up by 1, so that's 5/4, and we multiply by the reciprocal. And then we put a plus c, and then we do simplifying. So the 3's cancel, this reduces to 5. And then here, the 4's cancel. This reduces to 5. And our answer is 5x to the 5/3 minus 5x to the 5/4 plus c. And there's our answer for that one. Number 3 and following will incorporate the chain rule. For derivatives, or we could use substitution for integrals, but we've done these a lot, and we can make our guess, check it, and then change it if we're off by some constant. So in this first one, we want to, and for all of them, we want to look for our main function that's going on here. So this is something to the 5th power. So when we integrate something to the 5th power, we have 5x cubed minus 2. This goes up by 1. So to the 6th power, and then we multiply out front by a 6th plus c. So that's our first guess. Let's go ahead and check that. Checking, the 6 comes out front and cancels with the 1/6. So we have 5x cubed minus 2 to the 5th. And then we have to multiply by the derivative of what's inside. So that is, derivative of that is 15x squared, derivative of 2 is 0, and this does equal the original, so this is the correct answer. Moving on to number 4. Again, we want to look for the main function, and just to clarify, this program kind of does this funny. This negative 4x is within the natural log. Didn't mean to cross out the x there, but that's negative 4x inside there. The main function, however, is the 4th power. So we are going to integrate something to the 4th power, which means it should be that thing. So 4 plus natural log of negative 4x to the 5th, and then a 1/5 comes out front. Trying to make these parentheses a little heavier to see which ones go with what. That is our guess. So let's go ahead and continue with this. Let's check it. So the 5 comes out front. This is going to be 4 plus natural log of negative 4x to the 4th power. And we're going to multiply by the derivative of what's inside. The derivative of 4 is 0. Derivative of natural log is 1 over what's ever in there. So 1 over negative 4x. But then even within the natural log, we have a negative 4x, so the derivative of negative 4x is negative 4. And it looks like this is going to turn out to work. The negative 4's will cancel. And just checking, this is what's in the numerator in our original. And then we have x in the denominator, so that was the correct answer. So there's the integral.